1.4 reactions of organic compounds. Okay, this is the 11.4. Okay, so you can look at your notes. First, we are going to see bond breaking. We're going to see bond breaking in organic compounds. There are two types of bond breaking. One is called homolytic cleavage. The other one is heterolytic cleavage. Okay, homolytic cleavage and heterolytic cleavage. So first we look at homolytic cleavage. Homolytic cleavage ni kalau anda tengok dekat nota, if you see at notes, ada dua kriteria homolytic. There are not two criteria, few criteria. Most important one, it happens in non-polar bond. Okay, non-polar bond, when there is a breaking in non-polar bond, is normally homolytic cleavage. Okay, and second one, the atoms where the bond breaks should have similar electronegativity. Okay, electronegativity. So number one, homolytic cleavage occurs in non-polar bond. Number two, it involves atoms of similar electronegativity. Okay, and it breaks symmetrically. It breaks symmetrically. Okay, right. To make it easier, we look at the example. Example will give you a clear understanding. Let's say I take bromine molecule. Okay, under the sunlight, it will break into two atoms. Okay, and then we will have a dot here. Okay, a dot here. That means the bromine molecule here, this bromine molecule here undergoes homolytic cleavage. This bromine molecule. Reason, this is a non-polar bond, and atom of similar electronegativity. Atom of similar electronegativity causes non-polar bond. When they break symmetrically, and they break symmetrically here on the left and right is same. So the arrow we're going to use to show the breaking is half-aded arrow. Macam ini. It's called saya buat sekali lagi. It's called half-aded arrow. Okay, that means asalnya sini ada dua elektron. Okay, satu elektron akan pergi ke bromin ini, satu lagi elektron akan pergi ke bromin ini. That's how we get this one. And this one are known as free radicals. Free radicals are one type of intermediate species. Okay, dikenali sebagai intermediate species, type of intermediate species. So this is how we get the free radicals. So conclusion dia adalah homolytic cleavage menyebabkan kita hasilkan free radicals. Dan ini cara lukis free radicals. Kemudian dalam lukisan bagaimana kita tunjukkan homolytic cleavage? Half-aded arrow. Elektron ini tak perlu ditunjukkan, no need. Elektron no need. Okay, this is half-aded arrow. Okay, tak homolytic cleavage setakat ini? Ada soalan boleh tanya? Example Another example, we take CH3. Okay, you look at this example. Okay, hydrogen. So you can see here, this carbon and this carbon is same. This carbon and this carbon is same. And another important thing is, carbon and hydrogen electronegativity almost similar. Electronegativity of carbon atom and hydrogen atom is almost similar. That means what we can understand here is, sini boleh berlaku homolytic cleavage, sini pun boleh berlaku homolytic cleavage. Okay, there are two possibilities of homolytic cleavage. So I show you the first one. Let's look at the first one. The first homolytic cleavage is here. Okay, So we will get this free radical HCHH dot plus CHHH dot. Okay, so bear in mind this is homolytic cleavage. Okay, and it occurs between similar atom of electronegativity or non-polar bond. Let's say we want to show another one, that is between carbon and hydrogen. For example, kalau nak tunjukkan antara carbon dan hydrogen, so satu pergi sini, satu pergi ke carbon ni, maka kita akan dapat macam ini, dan juga kita dapat ini. Okay, all these are known as free radicals. Okay tak guys? And we must remember free radicals are produced from homolytic cleavage. Okay, between atoms of similar electronegativity or almost similar electronegativity. Okay, seterusnya kita pergi second type of cleavage, which is known as heterolytic. Ini lebih lain sikit lah. Okay, heterolytic cleavage. Heterolytic cleavage, you can look at the notes also. Dia ada definition dia sendiri. Heterolytic cleavage, dia kriteria dia obviously dia berlaku dalam polar bond lah. Maksudnya atom no same electronegativity kan. Electronegativity yang berbeza lah, different electronegativity. Not same ataupun different electronegativity. Different electronegativity. Okay. Dan dia, sebab dia different electronegativity, that will be unsymmetrical breaking unsymmetrical breaking lah. Okay, so example, saya terus masuk contoh katakan saya buat example ini kita tengok contoh sini BR. Okay, macam ni So you can see here, tadi kita dah kata this carbon and this carbon is similar electronegativity. So sini dia akan berlaku homolytic lah. But kalau breaking kat sini, itu totally different. Because carbon dan bromine electronegativity tak sama. So sini kita kena reverse balik ke SEM 1, flashback balik apa yang kita belajar. Bromine group 17 more electronegative than carbon. So that means kedua-dua elektron ini, kedua-dua bonding elektron ini, kedua-dua akan bergerak ke bromine sahaja. Dan perhatikan, saya gunakan full headed arrow. I'm using full headed arrow, not half headed macam homolytic. Pergi ke slide number 9, kita tengok kita guna half headed arrow. Tapi bila kita heterolytic, kita gunakan full headed arrow sebab semua elektron akan pergi ke atom yang lebih elektronegatif. Okay, so ini elektron tak perlu ditunjukkan. Saya hanya tunjukkan untuk kita punya understanding. Jadi apa yang kita akan dapat adalah ini akan jadi positive terminal, ini akan jadi negative terminal. Okay, sebab elektron semua pergi ke sana. Maka kita akan hasilkan anion dan cation. So this will be our cation. And Br ini asal kalau kita belajar dulu Lewis structure. If you remember the Lewis structure, dia asalnya dia ada 2, 4, 6. Okay. Bila 2 ini pindah ke bila 2 elektron daripada bonding masuk ke bromine, maka dia akan jadi 8. Sini 8. Dia akan jadi negatif. Ini adalah anion. Okay ke? Okay ke? Procedure must be correct. The procedure means what I'm telling the procedure here. You must show the partially positive, partially negative, the lone pair electrons, and the most important is the arrow. Arrow daripada bonding electron pergi ke bromine. So kita dapat anion. Okay, let's say we try another example. Let's say apa contoh saya nak tunjuk pada anda. Okay, tak apa, kita ambil ni. CH3, tak payah. Sorry. Macam ni. CHHI. Macam ni. So, sini tak ada homolytic Homolytic sini lah. Sini semua homolytic. Ini heterolytic. Okay, because we know that iodine is more electronegative than carbon. So, iodine become partially negative. Before that, kita boleh letak lone pair. Tak nak letak pun tak apa You don't want to put also can. Okay. Contoh saya bagi tahu yang tak nak letak lah. Katakan saya tak nak letak. So, since iodine more electronegative than carbon, iodine become partially negative, carbon partially positive. The bonding electron go to iodine. So, you will get CHHH plus Cl, bukan Cl, sorry, I plus I negative pun boleh. Macam ini pun boleh. So, we get cation and anion. Okay. Now, we have special name. Cation, anion ini sebab dia melibatkan, perhatikan dia melibatkan carbon tambah perkataan kat depan. Carbocation. Carbocation. Okay, so nama special dia adalah carbocation. So, in heterolytic cleavage, kita produce carbocation. This is another type of intermediate species. Satu lagi intermediate species. What was the first intermediate species? Free radical. So carbocation is the second one. Now we go to the third intermediate species, also from heterolytic cleavage. You can look at slide number 12. Okay. Let's say I have example carbon, hydrogen, lithium. Okay, contoh ni lithium. So this case, carbon is group 14, lithium is group 1. Obviously, carbon more electronegative than lithium. Okay, carbon more electronegative than lithium maksudnya kita punya carbon akan jadi partially negative, lithium jadi partially positive. So the bonding electron will move towards carbon. Okay, the bonding electron between carbon and lithium will move towards carbon. Therefore, kita akan hasilkan carbon, hydrogen become negative and lithium become positive. This is now the anion and this is the cation. And this anion has a special name, carbon ion, C-A-R-B, carbon ion. Okay, this is the third type of intermediate species. So altogether we have 3 intermediate species. 1 from homolytic called free radical, 2 from heterolytic, one known as carbocation, another one is carbon ion. Okay tak guys? Now bahagian yang sangat penting iaitu stability, or this one you must listen carefully lah. Stability stability of the intermediate species. So begin with, saya mulakan dengan ni lah, free radical. So I give you the arrangement first. Saya bagikan arrangement dulu baru kita cerita lah. Okay, so I have this radical. Okay, follow by, ataupun saya terus bagi order dia lah, senang. Nanti baru saya terangkan. CH. Okay, H radical, and then H radical, and then okay. Can you see what I write on the slide number 12? Boleh nampak ke? Okay, boleh nampak Okay. When the free radical surrounded by all hydrogen atom, itu radical dikenali sebagai methyl radical. Methyl because only hydrogen surrounded the carbon free radical. So it's a methyl radical lah. Methyl free radical atau methyl radical. Okay. Then bila kita ada satu hydrogen replace dengan CH3, one hydrogen replace with CH3, ataupun kita kata hanya ada dua hydrogen, then kita panggil dia sebagai primary free radical. Okay, primary free radical. Similarly, kita hanya ada satu hydrogen saja, ada dua alkyl group. Okay, for your information, ini group dikenali sebagai alkyl. Saya circlekan satu. Yang saya circlekan ini dikenali sebagai alkyl group. Okay, nanti kita akan belajar lebih detail alkyl group bila masuk hydrocarbon lah. At the moment, macam mana kita nak classify mereka? Kalau ada semua hydrogen di sebelah carbon free radical, dia adalah methyl free radical. Kalau satu hydrogen diganti dengan satu CH3, itu adalah primary. Ataupun carbon radical ni hanya ada dua hydrogen, then primary lah. So kalau ada satu hydrogen saja, maka itu adalah secondary free radical. Dan jika tak ada hydrogen langsung di sekeliling carbon radical ni, surrounding the carbon free radical ni, tak ada hydrogen langsung, maka itu dikenali sebagai tertiary free radical. Hydrogen. Kalau ada 3 hydrogen, methyl. Kalau langsung tak ada hydrogen, tertiary. Macam itulah kita faham lah secara mudah. Okay, now we are going to talk about stability. Stability, and this is the increasing order of stability. Okay, of free radical lah. Okay, increasing order of stability of free radical. This is the order. That means, who you think is the most stable? Methyl or tertiary? Tertiary is the most stable. So this is the most stable. Therefore, our methyl is the least stable. Paling kurang lah. Okay. The explanation, I give you the keyword. I give you the keyword first. Tanah dot lah. Keyword dia, more alkyl group, more stable. That's all. More alkyl group, more stable. Lagi banyak kumpulan alkyl, lagi stable dia. Okay? Boleh ke?
Boleh, sir.
Boleh Okay, kita tengok explanation dekat nota Dia kata stability of carbocation increases with the number of alkyl group present. Ini yang saya bagi tahu lah, more alkyl group, more stable. Reason, alkyl group is electron releasing group. So next term yang anda kena fokus adalah next term electron donating ataupun releasing group saya panggil EDG. Kena ingat selalu kena ingat. EDG maksudnya electron donating group. Okay. So alkyl group is electron donating group which will increase the electron density at carbon. Mana free radical ni? Sorry. Sini saya silap baca pula. Alkyl group is electron donating group which will increase the electron density at carbon free radical. Thus stabilize the unpaired electron of carbon atom. Nampak di slide 89 ada dia punya explanation why we say more alkyl group more stable. If more alkyl group present, alkyl group is electron donating group which will increase the electron density. Okay, more alkyl group present will increase the electron density around the carbon free radical, and thus help to stabilize the electron, unpaired electron of carbon atom. Itu reason dia lah. But keyword yang ni. Okay. Alright. Now, go to next slide. Kita nak tengok carbocation. Okay. Carbocation. Okay. Carbocation, dia punya drawing sama dengan free radical. So, CH, cuma dia positif lah. hydrogen, hydrogen, hydrogen plus. Okay, and then H3C, C hydrogen, hydrogen plus, then H3C, C, CH3, H plus, then H3C, C, CH3, CH3 plus. Okay, so this is methyl, this is primary, this is secondary, and this is tertiary. Tapi sekarang kita tengah cerita pasal carbocation. The good news about carbocation, dia punya explanation same as free radical. Itu good news dia. Okay, cara menerangkan mereka carbocation adalah sama seperti free radical, iaitu more apa tu more apa? What is more? More alkyl group. Good. More alkyl group, then more stable. Yes. So you can see contoh kita tengok, saya bulatkan. Methyl no alkyl group. Symbol alkyl group R R is the symbol for alkyl group. Methyl tak ada alkyl group. Sini kita ada satu alkyl group. Sini kita ada dua alkyl group. Dan sini kita ada tiga alkyl group. Okay. So since tertiary carbocation has the most alkyl group, then it is the most stable. Likewise, methyl no alkyl group, then it become the least stable, paling kurang stabil. Okay guys, okay, all right, then we go to the third type of species, intermediate species, carbanion. Carbanion dia opposite to carbocation, terbalikkan semua tu. That means dia akan jadi macam ni lah. HCHH negative, more stable. H3C CHH negative, more stable. Okay, stable. Kemudian H3C CH3 CH3 negative. So this is tadi increasing ini decreasing order of stability lah. Kalau anda tengok decreasing order of stability, you find that methyl carbanion is the most stable. Methyl is the most stable. Methyl carbanion is the most stable, while the tertiary carbanion is the least stable. So explanation, dia totally terbalik. Carbanion ini tadi kita kata carbocation is EDG, kan dia ada EDG R itu dikenali sebagai, kumpulan alkyl itu dikenali sebagai EDG. Lagi banyak EDG lagi stabil. Ini terbalik. Ini kita panggil EWG. EWG stands for, ataupun saya tulis dulu lah. Tak apa, kita gunakan EWG, bukan guna sekarang lah. Saya guna kemudian, nanti confuse pula EWG. EDG aja, kita guna EDG saja. Kita masih fokus pada EDG Still we focus on EDG. Now what happened? EDG the presence of EDG destabilize our carbanion. Okay, I want to repeat again. The presence of EDG destabilize carbanion. That means dia bagi elektron lagi banyak kumpulan alkyl. Kita tulis ni lah. let me write. More alkyl group than less stable. Like that. Okay, carbon ion more alkyl group, less stable. So perhatikan sini ada 3 alkyl group. So the least stable lah. Sini metil tak ada alkyl group langsung Jadi dia most stable. Okay. So kalau dekat carbocation lagi banyak kumpulan alkyl R ni, lagi banyak EDG, dia akan stablekan ion. Carbocation lagi banyak EDG, lagi banyak R, lagi banyak EDG, lagi banyak R, dia akan stablekan carbon positif ni. So tertiary adalah paling stabil. Tapi di carbon ion lagi banyak R, dia destabilize the carbon ion. Lagi banyak R, dia kurang stabilkan carbon negatif, destable.